everybody, and welcome to another OpenShift Commons briefing. Today we have Redbeard, aka Brian Harrington, and the product manager here at Red Hat for Istio, and he's going to give us an introduction to Istio 1.0. And happy birthday to Istio 1.0. It's great to have you. And I'm going to let Brian do all the talking here, and we'll have chat. You can ask questions in the chat. If it's life chattering, I will interrupt Brian, but otherwise we'll save them all for the end for some live Q&A. All right, take it away.
Excellent. Well, first off, it's my pleasure to actually be saying hello to everybody today. So excited to be talking to you about Istio. And as Diane was saying, it is time for a little bit of a party, because just a few days ago, we actually had Istio hit the official kind of 1.0 for the upstream, which is always exciting when you have that sort of thing happen with a project, because it gives a lot more confidence that the project is having a lot of forward progress and that things are getting, as I like to say, one step closer to boring. You know, boring in this sense is actually the thing that we are looking for, though. You know, boring is exciting because it means that we have a lot of testing going on in the project. You know, the 1.0 focus has really been on the testing, the upgradability. There was a lot of work that was done within the community of doing upgrades from the 0.8 release to the 1.0 release. They actually just for about a week before the actual release had a big push where they were getting members of the community from all of the various collaborator companies as well as individuals working on kind of making sure that everything would go as smoothly as possible. Because if you don't have a high degree of confidence that your upgrades are going to work, it makes it really hard to kind of promise to all of your colleagues and coworkers that this is the right answer that you want to take into production. And then another major component that they had going on was focusing on the incremental aspect of deployments. So that is to say that, you know, you can deploy Istio, and then when you have the different monolithic legacy applications that you need to get rolled out into production, that you can kind of start adopting the use of Istio piece by piece to get things to where you really are going to need them to be in the long run. That's it? Well, kind of. I mean, most of these changes were actually happening under the hood. That is to say that in the process of doing that, you know, they said, if we're going to say that this release is 1.0, we really need to make sure that when folks go to actually use it, you know, when they have their first experience, that 1.0 means that, you know, they have that degree of trust. And, you know, that's why there has been a lot of uptick recently also in the 4.0 project, which is doing the scaling and load testing. And that is where all of the work for Red Hat really kicks off. You know, one of the pieces that's been exciting to me is Jiali. You know, Jiali is a component that gives you a visualization of the entire application mesh that you're working on. You know, it gives you a nice graph so that you can kind of see where how all the different components connect together. And this is one of the aspects that, in terms of Red Hat, is something that we decided to lead on. You know, we saw that there was a need here, you know, that obviously if users are going to be deploying Istio, they're going to need more than just kind of the roll everything out and, you know, kind of cross your fingers and hope that everything is going to work. And so this then leads to, as I was saying, you know, the next steps here for where we are at with the collaboration between Red Hat and the rest of the community. And as is the case always with any piece of software that Red Hat releases, testing is the big component. That's both testing of the upgrade workflow as the community has been doing, it's the testing of the actual packaging mechanism, and it's ensuring that when you are rolling out these components, that it is seamless. We are also having a big focus on the actual user experience. You know, kind of hallmark of the Upstreams 1.0, the thing that they were focusing on with that was that they wanted to make sure that things were production ready in the core feature set. Now, production ready in the core feature set is not to say the entire feature set, which it is that entire feature set which is getting everybody excited. You know, that's the bullet points on the slide where you look and go, oh, okay, so they've got all kinds of stuff going on with the ability to control the actual traffic flow, to mutate it a bit, to get more observability into the entire application mesh, the ability to kind of inject additional some security components all along the way. And that is part and parcel of the work that we will be doing with Jiali as well. You know, we are also going to be focusing on more of an operator-based deployment model in the future here. That allows us to do the changes that we feel are more specific to what Red Hat customers explicitly want. And we've had folks inside of Red Hat who have been focusing on different areas like, you know, removing the need for running privileged containers for the actual sidecar injection process. Today, the sidecar injection requires privileged containers because of the mutation to IP tables rules on the hosts. And through using more of a controller-based model and then using operators to deploy those controllers and all of the other components, it allows us to start working through a process of giving each component the absolute minimum level of privilege that it needs to actually accomplish the tasks that are coming up. And then this leads us with the ability to, as we approach the kind of GA, which is going to be the next major step for Red Hat, achieving the OpenShift style multi-tenancy. You know, this is the kind of difference between the idea of just very soft multi-tenancy that they are working on upstream and more of the style of multi-tenancy that OpenShift users are accustomed to. You know, knowing that inside of your enterprise environment, that when you have two different constituents deploying onto the same cluster, that you have that higher degree of confidence in the actual stability and segmentation of the deployments. And one of the really nice things about the work that Red Hat has done up to this point is that you can actually play with all of this today. And when I say play with it today, you know, you can start learning how Istio actually works. And, you know, this is also a good opportunity to point out that you can learn any of the components of the entire OpenShift stack, because the folks from involved in OpenShift have used the kind of upstream kata coda mechanism to be able to provide both the a set of tutorials on learning how the different OpenShift components work in general, as well as the more specific aspects of the service mesh that is the thing that, you know, we're here to talk about today. So beyond just the playing with it today, you know, this is where I have talked to a lot of folks and understood that they hear service mesh, they know, they look at the basic bullet points of Istio, and then they go, but what does that mean for me? And how do I get the things that I actually want out of it? You know, what does this actually mean? What is a service mesh? And that's why we're going to take a second and talk about under the hood. You know, we've been running through this idea of we've built monoliths for a long time. We need to stop building monoliths. How do we do that? And the thing that we are hoping to see with Istio here is giving developers the ability to break down applications into smaller services and decentralize them. You know, that's the whole idea of containerization. And there's a good reason for that. It makes it easier to manage these services hypothetically. When you can build and deploy and scale them separately, it means that you can separate the concerns into different teams and really allow them to have the ability to work at the cadence that is most optimal for them and not have as many kind of hard interdependencies. I mean, that's the basic of distributed systems theory. And while we talk about, in this slide, microservices, what we're really talking about is building distributed systems. Distributed systems are not necessarily a new idea. This kind of goes far back, well before the idea of even, System 7 signaling within old, Bell Labs hardware. But ultimately, it's the idea of having a control plane and a data plane. The nice thing here is that, we have a lot of paradigms that folks have gotten used to with this. If you look at Kubernetes is this distributed system where you have both the control plane, which is the actual Kubernetes API, and then you have the data plane, which is the nodes themselves that are executing containers. And one of the hallmarks of any distributed system is that a failure of the control plane should not mean a failure of the data plane. So in the case of Kubernetes, like if that control plane goes down, if the API servers go down, none of your applications go down. Those applications are just going to stay scheduled on the host. It's just you can't execute a state change on them. And as we move to more of this distributed architecture, well, that's when you start ending up with a little bit of a spaghetti mess. When you break down this monolith into smaller services, you tend to get a lot of them, and as that number increases, the complexity of all the communication between those services increases too. What used to be kind of a function of a call from one piece of code to another in the monolith really just now is all API calls over the network, which we're relying on a lot more of the network characteristics than we used to. So as we decentralize these services, it's essentially pushing the complexity that used to just happen between sockets or IPCs on a host to different areas outside of the application, and that actually affords us a lot of new capabilities. So fortunately, folks inside of Red Hat, put together this nice slide that I like of kind of summarizing some of the fallacies of distributed computing, and this helps to understand why Istio is important. I'm sure some of you have seen this before, but as developers and administrators, we tend to forget about these a lot of the time. And it's important to note that when you're moving to building cloud native applications, we cannot be ignorant of these. We have to build all of this sort of resilience into our services. Werner Vogel, the CTO of Amazon, famously said, everything fails all the time. And if you're not actually keeping that in mind and working and building things with that mentality, it can definitely come back to bite you. So how are we going to actually deal with all of this complexity in the future? Well, fortunately, containers simplify all. This is something that I know everybody on this call is hopefully aware of. If you're not, please join the club. Between Red Hat and CoreOS, we've been really pushing the idea of containers for quite some time. It's nothing new. I mean, anybody who used to run Solaris, and had experience with zones or used to run AIX machines and had APARs, you're familiar with a container. So it's not like this is some newfangled fancy technology. We just really had a lot of focus on the deployment experience. Company a few years ago had a large focus around making it as easy as possible to track and kind of pull down those containers to your individual services so that you didn't need to deal with or care about that in the way that you had to with LXC or systemd nspawn. So this gets you to that build once, deploy anywhere sort of idea. So as long as you're kind of running on, a base operating system like RHEL, it actually doesn't matter whether it's bare metal, public cloud, etc. And this then gets you into having the challenge of the actual configuration management or the configuration of your individual applications. And as you start getting lots and lots of services, they need to be able to find each other. So, in the case of configuration, you have these config servers that folks started building, and then you had, the service discovery components that started being introduced as libraries. And, this is still at the state, though, where you have to change your applications to kowtow to these other services that are on the network. And this just kind of keeps going where, you can begin to utilize services like, Netflix Zool, but that's, again, just another library that's helping you, but it requires you making changes. And as you're kind of standing on the shoulders of all of these different libraries, you're having your developers make more and more changes to your applications until finally you're in the state where you really are kind of building out everything in the way that somebody else says to, not necessarily the way that your developers were ready to when they started on day one and had all of this knowledge that they were kind of coming into your organization with and why you hired them. And it means that, for the next month, hopefully less, possibly more, they now have to learn how to use all of these libraries and how your processes actually work. So what about the state of, the applications that you have already got, or even worse, these 6 different applications that you want to find some way to make them work together, but there's no clearly defined path. One of my favorite pieces of software that serves purposes like this is this component called OAuth 2 proxy. At CoreOS, we used to use it all the time. It's really just this thing that you can use to inject headers with that then allows you to do basic like OAuth style fronting of an application so that you can say, okay, the backend application, we just kind of punt on having to worry about how we actually incorporate all of the actual authentication services, because we push that off to this other microservice, which solves that problem for us. But if you don't have all of the other pieces in place, like if you're not utilizing something like Kubernetes so that you can bounce between all of these different services, it can definitely be pretty challenging. And there should be a better way to actually achieve this. The thing that we're trying to do is address all of the complexity of all of this infrastructure and, automating the container deployment. The automation of that container deployment, that's where OpenShift comes in. That's where Kubernetes comes in. And this gets you to where, you build all of these cloud native apps with OpenShift. You kind of utilize ROAR and everything else. But let's hold on here a second. Y'all joined this call to hear about Istio. We talked about, what does the transition from 0.8 to 1.0 mean? I said that I was going to explain more of what this service mesh stuff is for the folks who weren't familiar with that. But all that I've been doing is talking about the way that things were. Well, in reality, I was talking about the way that things were. But really, we're talking about the evolution of what this means in all of these microservices. As we started with a platform years ago, we had all of these libraries that you were going to have to integrate into your applications and ways that you were going to have to change everything to make them work. And really, that's not always the best path. If you can start to do things, if you can start to achieve all of these goals without fundamentally changing all of your applications, if you have all of the supporting services for building distributed applications in the actual container platform itself, it means that you are kind of making services responsible for dealing just with the thing that they care about, and you're standing on the shoulders of the infrastructure that provides you with answers to all of those cloud native concerns. you want to be in a situation where each platform is responsible for providing those services. That is the goal of the platform. And so in the idea of kind of the service mesh architecture, we have this idea of having proxies that get injected into the individual pods, and then again, in distributed systems theory, the idea of a control plane, which is what Istio actually is. Istio, with the exception of Jaeger, really is all of those boxes at the top, Pilot, Mixer, Jiali, and Envoy, but it is separating out so that Envoy executes the data plane and those other components execute the control plane. And what this does is it starts building in the ideas of fault tolerance, so that now you try to build systems of fault tolerance. Like, when you don't have Istio, it means that any kind of TLS communication that you want between the services, you have to handle either yourself or have your administrators take care of it, or building into the actual service code the mechanism of retrieving certs, doing cert rotations, etc. And depending on the programming language and the frameworks that you're using, that implementation can vary extremely wildly. Like, all existing applications ultimately are going to have to get refactored in some way just to handle TLS communications. Whereas with Istio, because all of that traffic goes through the Envoy proxy, it ends up being transparent. For the folks who have been around a bit longer and have mangled some of these sorts of things under the hood, you can kind of think of Istio as operating more as a socket-driven model, or more as like an S-tunnel type component. Istio, or Envoy in this case, is actually mediating both the ingress and egress traffic to the pod. So it means that your application only ever needs to know about communicating with this one other component that will always be in the same network namespace. So it's very, very predictable to make sure that it is sending and receiving traffic in that way. And by having the Envoy the Envoy in there with Istio acting as that mediator of the traffic, it also allows you to actually have more visibility into the individual response times and knowing what the exact state is of communication between different services. This allows you to actually configure individual timeouts and retries that all become transparent to the actual services. It also allows you to do rate limiting, so that if you have services that need a little bit more help, they can't handle necessarily just a flood of traffic, or you need to be able to implement kind of these load balancing type rules at different levels, you can actually specify these through policy, which will allow you to protect against, either huge amounts of traffic like denial of service attacks, or, potentially just beyond what they're able to accommodate. And that's just one component of being able to deliver on additional security to the services. But as we were saying, without Istio, you end up in a situation where the TLS communications are all kind of coupled in the source code. And that's really pretty suboptimal. It's easy to look at that and see, oh, well, if we have Envoy, which is actually communicating between all of these services, then yes, the communication within that first pod from service A to Envoy, that may be traffic that's in the clear, but that is also never in the clear outside of its network namespace. And then because Envoy is mediating that traffic, it can handle the issue or the request and rotation of the individual certs that make it able to communicate with all of those other actual pods. And because it is doing that with TLS-based communications, it also means that you can actually control how those services communicate. You can make it so that it's more of a model of client-based cert access than just strictly, can component A or is component A signed just by this general CA? Yes, then move on from there. This gets you to the exciting capability here of the concept of chaos engineering. In the past, if you wanted to do that sort of thing, you have your continuous deployment mechanism like Spinnaker, and then you have these other components like the entire Netflix Chaos Army, from Chaos Kong, where you can just destroy an entire VPC, all the way down to Chaos Monkey kind of nuking individual services. And that is useful in so much as, yes, you're actually doing some of the things that you should be doing, of testing resilience of your services and making sure that everything works the way that you would expect it to. But it's even better when you can just constantly be doing that and not have to start spinning up more and more infrastructure just to be able to do that test. Using these mechanisms, you can actually inject delays that are transparent to the service. And why would you want to inject delays? Well, obviously, testing is that will become, a mantra that you'll start to embrace over time. Testing. But for anyone who's read the Google SRE book, they have a great section talking about the idea of service level objectives, not just service level availability. And in a service level objective, you want to make sure less that things are always up. It may be a consideration that you want your service to be more consistent. They realized with the internal service Chubby at Google, which for anybody who's not aware, Chubby is analogous to etcd, that when they allowed developers to just talk to Chubby as fast as possible, developers obviously would talk to Chubby as fast as possible. When, on the other hand, they set the expectation of saying, no, your latency will always be in this exact window. A request will never take less than 5 milliseconds, but it will also never take more than 100 milliseconds. It meant that even when things were going slower than that 5 millisecond mark, it was really acceptable for users because it got to the point where they had a more predictable outcome. And I'm not saying that with Istio you want to just always inject delays on all of your requests, though. As an aside, Dan Kaminsky, the kind of just gentleman who discovered the famous bind bug back in 2007, he had a really awesome idea for kind of not necessarily hiding your services, but making it harder to profile them. It's based on the ideas of, I believe he was a physicist named Boltzmann, of a Boltzmann filter, where you intentionally inject small amounts of latency and randomized delay to your services, because it means that it becomes harder to profile their location and how they're actually interacting inside of a larger system. And these are the kind of advanced ideas that just come as a part of the overall package. So then we need to keep moving on, though. We have these ideas of being able to inject protocol-specific errors. That's the nice thing about Envoys. It actually can act as a layer 4, and layer 7 proxy. So it can do protocol-aware functions. But we also get into dynamic routing. So without Istio, we have these service discovery mechanisms and these kind of custom routing libraries which try to do more of that intelligent load balancing and routing. These are going to be things similar to other Red Hat products that you may have used. But with Istio, we get to the state of having all of that intelligence be in the platform, so that you can start to say, okay, if users come through and we annotate them with a header that says that they are located in Boston, we can actually do more globally aware mechanisms of kind of making sure that certain users go to certain versions of the service. So, here we're using everybody in Boston as the guinea pigs for testing out V2, of our internal B service. And, we know that those users in Boston, they're super advanced, they're willing to kind of bleed a little bit in order to serve the greater good for everybody. And so this gets us to where, we can actually have more incremental deployments and incremental changes. It also allows us to kind of split the traffic off. Now we can say, okay, it went well with everybody in Boston. Now we are going to take a quantile of that traffic and move it over to this other version of the service. Is it still looking good? Is everything, working great with that? When you are doing that, it also, beyond just kind of doing those A/B deployments, beyond doing quantiles of traffic and, the kind of, like we were saying, kind of shadow rollouts just for those folks in Boston, we can also do mirroring of the actual traffic so that you can say, okay, we know that everything on service B in version 1 is looking good, but we want to actually fork a copy of that traffic to version 2 of the service and actually see, is version 2 ready for prime time? Is it actually kind of standing up to the load that we expect it to? Is it getting everything done? Are we ready to roll that out and start to bleed all the traffic across? And then you can start to see, okay, well, if you start here and go, okay, we deploy both versions of the service, we have a mirror of all of our traffic go to version 2. Are we getting errors? Cool, we're not getting errors. Now, we start rolling it out just for the Boston employees. Are the Boston employees happy with it? Is it getting done what they need to do? It is. Great. Now we can start to roll that out to half of all of our users. Is everything still looking good? It is. And then finally, you finish the migration of that traffic. And Istio is giving you the knobs and the control mechanism to execute that policy of making sure that your application is actually working the way that you need it to. Now, this gets outside of, any of the stuff that, is directly affected by the 1.0, but one of the things that we are presenting as a part of the entire service mesh solution is distributed tracing. As you have that entire spider web of services, you need to begin to be able to see how the services are interacting between each other. If you have 25 services all having some type of intercommunication, and you all of a sudden see, the response time goes down to, 5 seconds to serve a request, or even worse, 30 seconds to serve a request, which one of those 25 components is the one having a problem? Well, in the past, if you had all of the other infrastructure set up, you might incorporate one of these libraries into your service and then set up a tracing server to kind of push all of the traces to, and then try to watch them and, profile it that way. But what if you didn't build that application? What if it's some, commercial off-the-shelf piece of software that you don't have the source code to, so you can't make those modifications? Well, in the case of, deploying these sorts of systems with Istio, we can actually begin to see, okay, from communicating from service A to service B, we had a 210 millisecond. Oh, and between service B and service C, there was 720 milliseconds. Well, yesterday that was only, 100 milliseconds. So what's going on? Did we deploy a new version of service C? Is there some kind of header handling between service B and service C that got mucked up? What's going on with this? How do we actually solve this? And when you're using Istio and Jaeger together, and then kind of introducing Jiali on top of this, it gives you a more complete answer for actually having a holistic view of how all of your services are intercommunicated. The takeaway. Ultimately, we are trying to build the distributed service platforms that folks are going to need. And this is where we as Red Hat scour the communities of practice within the world of open source, and we begin cherry picking out the individual components that we see high degrees of value in and that we see will integrate very well into the tools that our customers are adopting, like Kubernetes, that are giving them the ability to take and actually deploy systems and deploy services in the way that they need to and make them most efficient so that they can actually achieve all of the goals that they have, which are ultimately, none of us are actually in the software business. We're not. We are in the business of trying to serve value to our customers, and the way that we do that is often by utilizing software, and even more so in software that possibly we're building. But in the second decade of the 21st century, effectively all of us are utilizing software to get this done. So how do we start to build these platforms together and operate them in consistent ways so that we can go back to focusing on the thing that our customers love us for, which is actually providing the value that makes our customers fall in love with us and keep wanting to utilize all of our services. And thanks.
Well, that was awesome. That was much more than I actually thought you were going to do today. Usually when I ask someone to come and do a briefing on like a new release, I get like the white back screen with the 10 bullet points of what's in this update. And this has been really thorough and great. And I'm hoping that some of you might have questions. So
well, you did give me an hour, so I tend to like to, fill it up as much as possible.
There you go.
One thing that I will throw in here just to make it as simple as possible, I'm going to drop a direct link to the learn.openshift.com. That way, anybody who's in here can literally just click on that and
and I think Diane Fedema, I'm just going to unmute you. I think you might have a question here.
I do. You want us to
take
a question or just go?
Ask the question. Go for it.
Okay, so I was just curious about Istio. Then I'm just curious about what protocol it speaks. So the services are speaking HTTP to each other, and then under that, TLS is making sure that it's secure, but the person speaking HTTP doesn't have to think about the fact that the TLS is there. Is that how this works?
So I will answer that question, but I have to, inside CoreOS, we always had this joke that there's a redbeard explanation, which is, I go on these wild tangents, but I always get us back to the beginning. So one of the things that I mentioned was that Istio is acting as a layer 4 and layer 7 load balancer. So in that way, Istio can just operate as a simple, TCP, UDP, et cetera, load balancer, completely agnostic of the underlying protocol. That's one of the features of Envoy. It can also act as an HTTP proxy, and that's honestly the way that I expect a lot of our users to utilize it. Inside, with all of its intercommunication within the kind of components themselves, it's actually operating as gRPC, if I remember correctly. So it kind of, if you think about it, is going from there may be an inbound HTTP request within, like inside of Envoy, it's operating as gRPC, and then it may re-egress as HTTP. Independent of that, though, like the way that, like that software that I talked about, S-Tunnel, actually works is it would set up you can think about it as like a TLS or SSL-based VPN, where like your VPN doesn't really care what the underlying protocol in between is. It's just more like, hey, I have, kind of the inbound side of the pipe over here, and then I know that my traffic is encrypted, and on the outbound side, it comes out. So that's how, to answer your question directly, it's working in this case. Envoy will take and actually encapsulate that protocol, whatever it is, inside of a TLS connection between the two different services. And then when it egresses out the other side of that, proxy tunnel, it then reemerges de-encapsulated as the original form that it was.
Okay. But it can't go down the stack, right? I mean, it's above TCP. So,
Well, so it's encapsulating that traffic in TLS. So kind of in the same way that you can take an IP packet and you can put it inside of an IP packet, or
okay.
in the way of like VPN, you may take that like HTTP packet and then you would kind of encode it into, a GRE packet to then push that over a GRE tunnel and then de-encapsulate it and pull it back out. Istio is operating in a similar fashion.
Okay. But primarily people are using HTTP to talk between services?
A lot of users are, and that's just because, a lot of the services that they're building are HTTP-based services.
Okay.
It's kind of become a lingua franca that folks are used to. Though, there are a lot, like one of the big things that folks are excited about with Istio and Envoy is the fact that it can operate as a gRPC load balancer. One of the big things that they were working on with that 0.8 to 1.0 transition was the ability to use WebSockets and be able to do the update without necessarily destroying the WebSockets, which is pretty awesome when you think about that.
Yeah. People can write their own RPC code between applications, and Istio can help with that too, is what you're saying.
Yep, exactly.
Okay.
Perfect.
Cool.
We have a bunch of other questions that are coming in too. Phil's asking, and I think he has a follow-up too, what does Istio provide for app properties injection?
There are both, there's the rules engine inside of Istio where you can use Istio CTL to kind of manipulate some of that. If I remember correctly, you can also utilize the labels mechanism within Kubernetes to pull additional properties. And in like the HTTP case where you actually have deeper knowledge of protocol itself, you can end up injecting headers into that request that you can then take action on. There's actually a super awesome paper that Google wrote a few years ago, or I guess published a few years ago. The internal engineers wrote it, which I have been tracking for a long time. And at first glance, Istio seems completely orthogonal to it. The paper itself is called maglev. I'll pull a link to the maglev paper and put it in here. But maglev itself is talking about how load balancing works inside of Google. And the rad thing about it is that it is all described in one way or another as commodity technology. They make it very clear. We use equal cost multipath routing within the data centers, which is implemented through interior border gateway protocol, BGP. So they actually give equal cost routes to the different machines that are kind of the next hop in their load balancing mesh. And then they may actually nest these load balancing meshes one on top of another on top of another. And as you do that, though, you run into the exact challenge that we were talking about in like that spider web of services. How do you actually trace that packet, which may be going through 6 different load balancing tiers before it finally ends up where you need to go? And they kind of hand-wavy describe how they have this tracing mechanism, and they use their load balancers to inject these tracing headers that then tell the entire system to either fork out copies of that packet to the tracing system or to just kind of send back telemetry at each tracing layer. And now that Istio is released, this paper that I was reading years ago just makes absolute sense. It's like having these two lenses that over time are slowly turning in opposite directions, and then the polarization aligns and the laser gets through and everything makes sense. I know we have a growing amount of questions though, so this is going to be a little bit of a challenge.
So pop into chat. Yeah.
Okay, so
there's a whole bunch of them, and then afterwards we'll throw you all in Slack and make you talk too.
Yes. Okay, so we talked about app properties. Oh, yeah, and so somebody else mentioned, config maps as well. What are the cons of adding this Istio control plane in Envoy? Is there a price? Okay, yes. So as with anything, there is a cost. When you are kind of doing IPCs within, a single, we'll say a single kernel, the amount of latency that you are going to have is probably measured in nanoseconds to the high-end microsecond. Now, when you're doing IPCs over a network, there is going to be more latency introduced. And so ultimately, that's part of the cost that you are paying there. You're making the deliberate decision that instead of having your developers understand all of the nuances of integrating with these dozens of libraries, you're going to shift that to the actual application. And as long as you know that the platform stack, as long as you can trust that the infrastructure will be able to increase in speed over time, that you know that you'll be able to kind of keep up with some of that. And one nice thing is that with the fast data project, which is fd.io. So fast data is working on standardizing a set of APIs so that you can do what's called TCP offloading. That's also described in the maglev paper. They mention using it with one specific mechanism for a vendor called SolarWinds and another mechanism from Intel called DPDK, the Data Plane Development Kit. Fast data is standardizing all of those APIs so that you can begin to say, okay, we're going to have kind of TCP offloading implemented at the actual kernel or user space level, not the kernel level, so that it can operate as absolutely quickly as possible, and we can start to decrease some of these actual latency hits and everything else. So Narayan asked a couple of questions. Are there rate limiting and circuit breaking limited to the local instance of pods or to all the pods of that service? Meaning, if my service B can only take 300 a minute, do I need to configure 100 a minute over 3 instances? So you can actually configure it at the actual service level. And that's actually a good point in the difference between like gRPC and HTTP is within the implementations themselves, it's actually a little bit more nuanced than that, because in some cases you can say, well, this application, we measure the health in different ways. Maybe we are saying that it can look at a total number of requests over some, period of time. Possibly it's you start shifting the traffic based on if it is using too much memory, or if it's getting starved of millicores, in the Kubernetes sense. So in the case of gRPC, because I was reading through the issue yesterday on the Istio issue tracker, they actually end up with a situation where they don't have as rich of telemetry for gRPC connections. So they were suggesting at the moment as a triage until they can get it kind of more generally fixed, dialing down the number of total connections for a particular service. So not to a pod per se, but say, okay, we need to lower it down overall so that it splits it a bit more evenly, so that you can actually achieve that mechanism like you were saying. So I hate to frame it this way, but the answer to question 1 is it depends. It's largely based on what the protocol of your service is, what types of kind of health checks it's able to do to see the state of that. And then with Istio, are distributed tracing patterns good to use with 100% sampling? Are there rules we can turn on the control plane to dynamically turn off during failures and high response times? And I must cop to ignorance on that. That level of detail when it comes to the tracing is outside of the wheelhouse of which I've been able to kind of get a grip on at the moment. But the rad thing is that's the sort of thing that I add to my list of things of like, well, what did it take to do that? Because I can, if you're asking about it, other people are definitely going to ask about it too. So back to Phil, can a property and multiple config maps be changed? Well, so that's going to be, config maps are more just, a mechanism of Kubernetes. So that's going to lead to, can Kubernetes do that? And yes, you can. I mean, that's getting into the difference between create semantics versus patch semantics. And, you would want to kind of batch those changes together, if I'm understanding your kind of question correctly, as like a transaction to patch multiple things. And Istio kind of stands on the shoulders of Kubernetes in that sense, rather than directly executing.
So almost to the end of our hour, but there's still a couple questions. Phil asked one more follow-up. Can config maps, have a hierarchy?
I don't think so, though I am quite possibly wrong on that. It would not be the first time I've been wrong, and it will definitely not be the last, but I don't believe they can. And then
even deeper dive briefing coming soon in our future to answer some of those questions. So there's one, Tanim is asking a beginner question. Maybe that's a good way to do it. So if Istio becomes the load balancer for Ingress, then do we replace it with HA proxy in the future? Then Istio control plane will run in info nodes. And John's
John actually had a pretty good answer there of saying that, it doesn't really run a cluster-wide router. It's just kind of load balancing traffic with the sidecars kind of co-located with the application. One thing that I should say is, with the kind of 0.8-ish into, or fuzzy from earlier versions into 1.0, Istio did have a concept that mutated a little bit of moving into what's called a gateway. And so they implement this idea of gateways, which are kind of their own specific API spec within the actual structures that are getting laid out. And, the thing that I've been interested in is, in talking about kind of the ideas of that maglev paper and utilizing the idea of Kubernetes cluster IPs, which are, it's closer to like a VRRP style moving an IP address around, though it's really, no, it's less that. It's kind of like having an IP with a /32 subnet mask that listens on every single node. And so if you route traffic to that node, it knows how to answer and then kind of respond on it. And so if you did that, you could use that to then actually use your network router to kind of get the traffic into the cluster as the load balancer. And then from there, Istio would be able to kind of take that traffic and then move it around the cluster. So it's a thing where you end up kind of combining some of the primitives of Kubernetes and OpenShift with the kind of capabilities of Istio to solve those problems.
Well, I think that might be all we have time for today. And Redbeard, that just is was amazing presentation. So I'll try and get it uploaded to the RH OpenShift YouTube channel later today, probably with very few edits. And then we'll post it on blog.openshift.com with some of the links. If you send me your slide deck and the links to the past data and the maglev paper and the books and all the references here, I'll try and get them all into the blog post too, so that we can have those. It really is a pleasure, and I'm looking forward to hearing more from you guys and doing more kitchen talk with Redbeard.
Of course, happy to be back, and kind of spread the fun awesomeness of, the modern infrastructure development. It's the thing that always gives my spine a little bit of a tingle.
Awesome. Take care, guys.